In this problem, what we're going to do is we're going to go ahead and figure out the theoretical yield when we are starting with moles. It's a pretty basic limiting reactant problem, but it's the basis for every problem you do, so you really want to make sure you master this. You can see that the first thing this reaction or this problem wants us to do is go ahead and write the balanced equation between zinc and hydrochloric acid. So zinc is Zn, hydrochloric acid is HCl. And if you remember from last year, this is a single replacement reaction, which means the zinc is going to try to replace, in this case, hydrogen from the hydrochloric acid. So we know hydrogen goes off on its own, hydrogen being a diatomic gives us H2. And then zinc chloride is our other product that's formed here. One of the things you always want to make sure you do whenever you write one of these equations, or really do any of these problems, is make sure it's balanced, because that is going to make the difference in solving this problem, because we're always going to have a mole ratio. So always make sure you balance the equation. If you have any questions on writing reactions or balancing equations, you might want to go back and review some of the stuff we did last year. One of the things that makes this problem a little bit different as the ones we did last year is the fact that instead of just one quantity, it actually gives us two quantities. That's important to note, because when you have two quantities, you have to first of all figure out what the limiting reactant is. Once you know the limiting reactant, then you can go ahead and figure out what your theoretical yield is. Now this problem says do it in your head first. What does that mean? Well, it means just to look at the mole ratio that's actually given and what we actually have. If you notice, the mole ratio that's given is 1 to 2. 1 mole of zinc requires 2 moles of HCl. And if you think about it, we've got 0.30 moles of zinc. Okay, well, the ratio is 1 to 2. So if we have 0.30 moles of zinc, then we should have twice as much hydrochloric acid to actually react that. Why? Because we want to maintain that 1 to 2 ratio that's in our balanced equation. So how much hydrochloric acid should I need here to maintain that? Well, to maintain the 1 to 2 ratio, it looks like we need 0.60 moles of HCl. And as you can see, we don't have that. So it looks like HCl is going to come out to be our limiting reactant in this problem. Let's go ahead then and actually solve this mathematically and figure out then what the actual amount actually is. All right, so what you want to do is you want to go ahead, take both your given quantities, in this case 0.30 moles of zinc and the 0.52 moles of HCl, and we want to convert them both to the product that we're looking for. In this case, it's the hydrogen. And in this problem, like I said, it's fairly straightforward because we have moles already. So we can just do our mole-to-mole ratio here to get that. Moles of zinc, of course, cancel. Numbers in the mole-to-mole ratio, of course, come from the balanced equation. In this case, for hydrogen to zinc, it's 1 to 1. Comes right out of the balanced equation. And for the HCl, it's going to look something like this. Moles of HCl to moles of H2. One of the things you want to remember is you've got to get these to the same unit. And you can see there that in this particular problem, I've gotten them both to H2, that substance that I'm looking for. Once you've got them in the same unit, you're pretty good to go here. Get our numbers in here for this. It looks like 1 mole of H2 to 2 moles of HCl. Again, comes right out of the balanced equation up there. And let's go ahead and solve both of these. This top one is going to be 0.30 moles of hydrogen. And the bottom one is going to be 0.26 moles of hydrogen. The important thing to remember is once you have that, the one that is lower is going to be your theoretical yield. In this case, looks like that is lower. That's our theoretical yield, which I'll abbreviate with a TY right there. Also, that theoretical yield, if you remember, is determined from the limiting reactant. What actually determined that 0.26 moles of H2? Look at that, it was the HCl, and that's what we predicted was going to be our limiting reactant. So, yep, HCl is our limiting reactant. Zinc then is the excess substance. There's going to be some of that left over, which again, we predicted at the beginning of the reaction. One of the things I think is probably the most important thing that you remember when you solve a problem like this is to make sure that you get these quantities to have the exact same unit. If they've got the same unit, you're good to go. If you've got something other than the same unit, then you know you really haven't solved the problem correctly.